今天来讲一下 negative r squared 三部曲中的第二步，也就是最重要的一步。在这个视频当中，大家可以直观的看出来，当一个 model 非常非常 bad 的情况下，它可能得到一个 negative r squared， 或者它得到一个 r squared even greater than 1。一言以蔽之，就是当这个 model 非常 bad， 也就是说，本来可能是一个 non-linear model fit the data better， 你非要用一个 linear model， 而且你非要让这个 linear model pass through origin， 所以这样的话，对于每一个对应的 x， 你都得到一个非常 biased 的 expected value of y，even worse than the average of y。所以你可以看到，你可以看一下，在这种情况下，你可能会得到一个 negative r squared， 或者是 r squared greater than 1。但是我们其实在这种情况下发生的时候 ，if this is the case， 我们其实用一个不一样的 formula to calculate r squared， 这个留给最后一步，三部曲的第三弹最后一步再讲。这个视频主要是讲一下 intuitive understanding of negative r squared。by the way， 这里 r squared 不是 adjusted r squared，OK， 就是传统意义上的 r squared，the fractional variation of y explained by the model. Okay, let's get into it. And now to understand in what situation you have a negative r squared, just use this logic. A negative r squared and give you this, a negative r squared. So we have this y, x. Suppose this is your scatter plot. Okay, scatter plot like this. So the average is here. Maybe this is average. So this is a y bar. Okay, now if you use average to estimate y, the estimation error will be average minus y1 plus average minus y2 plus all the way to average minus yn. Okay, so that actually is the sum of squared total equals sum squared deviation from the average. So graphically is this squared plus this distance squared plus this distance squared, right? You get this sum of squared total variation in y. This blue line represent the distance represent the estimation error when you use x bar as the estimate. Okay, and squared, you get this term. And now if the regression line look like this, just draw a regression line. You just draw a line through these points, but you force this line to pass through the origin. So they'll be like this. So now this is y hat equals pass through the origin b1 times x. So now you are not using y bar, right? You're using x for each value of x. When x equals, let me use this color. When x equals x1, observed value is this much, but predicted value is on the line, right? When x equals x2, observed value is here, but predicted value is here. So you have all the value, the predicted value is on the regression line. So now you're using this point on the regression line to estimate the value of y. So now let's look at this sum of squared model and then sum of squares error. So look at sum square error first. So that'll be sum squared predicted value minus observed value. Look how large that is. So we have this, right? This is estimation error, right? This estimation error. First term is y1 hat on the line minus observed value of y, the here. This is estimation error squared. If you're using average, you see this blue line, the error is a lot smaller, right? And then second term, y hat 2 minus observed value of y2. This is 1 squared. So it's this much, right? This is a predicted value of y, this is observed value of y, right? This white point, and which is also larger than the difference between average and observed value of y. So same thing, just to point at all the estimation error. The estimation error is a lot larger than sum square total. y hat n minus yn squared. So this is sum square error, right? Is this term is sum square error. So sum square error, just by looking at it, right? By looking at it, the difference, sum square error is greater than sum square total. And then if you use our traditional way to find r squared, that's 1 minus sum square error over sum square total. So this numerator is greater than denominator, this is greater than 1. 1 minus value greater than 1, this is less than 0. So now you have negative r squared. In other words, how do we interpret that? If you're using x to explain y, if you want to use x to get the predicted value y, this x does even worse job than the average of y. So this regression line does even worse job than a horizontal line. So this regression line can give you a worse prediction than the average of y. If you use average to predict the value of y, this is estimation error, right? Sum error squared. If you're using average to estimate each value of y. However, if you are using x to get the predicted value of y for each observation, this is estimation error. This estimation error is even greater than this estimation error. So that means this regression line does an even worse job than average. This regression line does even worse job than the horizontal line. So this is a very, very bad model. And also, you can interpret this r squared because r squared is supposedly a fraction of total variation of y that can be explained by the model. But here it's negative. You can have negative fraction. So if this is the case, r squared does not have the usual meaning or is meaningless. Or in other words, put another way is we have different way to solve for r squared. We have different way to solve for r squared. This r, if you use this way, this formula to solve for r squared, actually it doesn't make any sense. Okay, you should have a new way, a new method, or new formula to calculate r squared, which makes more sense. I hope you find this helpful. And 下一个视频就是一个 final 了，就是第3步，也就是讲一下到底应该用什么样的方式，用什么样的方法去 calculate 所谓的 r squared。当你这个 regression 没有 y-intercept 的情况，其实你可以看到用 traditional way fractional variation of y explained by the model， 我们可以得到一个 negative than 0 r squared, which doesn't make any sense, right? Which doesn't make any sense. 但是其实有一个方法可以 calculate 这个 r squared 还是 make more sense， 还是 make sense 的。所以我们下一支视频就来讲一下，就是到底该怎么样，在这种情况下到底该怎么样计算 r squared。Okay, so hope you find this helpful and see you next time. Bye.